Hi everyone, here is the next video. This is example 3, and we are finding the following: the limit as x approaches 0 of x over the absolute value of x. Now, if I were to make a table of the graph, let's just go -3, -2, -1, 0, 1, 2, 3. If I were to look at the graph there, -3 over the absolute value of -3 is -3 over 3, which is -1. -3 divided by 3 is -1. This is -2 over the absolute value of -2, which is -2 over 2, which is -1. -1 divided by +1 is -1. 0 divided by 0, this is undefined. Can't divide by 0. You can never divide by 0. Now, if you do 1 divided by the absolute value of 1, that's 1 divided by 1 is 1. 2 divided by the absolute value of 2 is 1. And 3 divided by the absolute value of 3 is 1. So if I look at the graph, this is a piecewise graph, it looks like to me. Let me just put up here -3. Let's make this -1 and this +1. -3, -1 is here, -2, -1 is here, -1, -1 is here. We are undefined at 0, so we kind of have this part of the graph when x is negative, and at 1, 1, we have a point, 2, 2, 3, 3, but we are undefined. If it was positive 1/2 over the absolute value of 1/2, it'd still be 1. So I am right here. Okay, as I approach 0 from the left, I'm going to -1. As I approach 0 on the x from the right side, as I approach from the left side, I'm going to -1. As I approach from the right side, I'm going to +1. I'm going to two different places. And whenever that happens, if they're not going to the same place from the left and the right, the limit does not exist. All right, one more example. So I'm looking at the limit of cosecant x as x approaches pi. All right, we got a little bit of remembering to do here. Cosecant of x. What are the asymptotes for that? Okay, that's when the sine of x equals 0, and that happens at 0 and pi and 2 pi and so on. So 0 is an asymptote, pi is an asymptote, 2 pi is an asymptote. Having trouble saying that. -pi is an asymptote, -2 pi is an asymptote. And then at 1 and -1, don't know if you remember that, but that's kind of the either max or mins for each of these. So, okay, I'm a little ahead of myself here. I don't know if that's right or not. On cosecant, 0 to pi, those are positive there. I'm wrong on this one. Let's draw. This would be down here. First mistake of the year. And this one just alternates. Remember how those guys alternate? You got this one. So I draw the graph here. Okay, and let's look. As x approaches pi, so right here's pi. Let me just get on this curve. If I go to pi from the right side, this is going to, the closer I get to pi, the further down I go. This actually goes down to negative, and whoops, that's not how you draw infinity. Negative infinity. And as I approach it from the right, let's just follow this curve, and I go closer and closer to pi here, I'm actually getting close to positive infinity. We're going to two different places as we get close to pi, from the left and from the right. So the limit here, when that happens, when it goes to two different places from the left side and the right side, the limit does not exist. In these periodic functions, sometimes that happens. Okay, that's all I got. You do have an assignment, page 758, numbers 33 through 40. I will also, in this assignment, if I haven't said so already, am posting a step-by-step process for you to get your notes and your book work onto PowerSchool. Get both of those on there together. Guys, take care. God bless you. I miss you. I hope we get to see each other before this is all said and done.